All right, when we are doing elimination, the goal is, Quaterion, are you paying attention?
Yes, your goal is to
get a variable to eliminate. All right. You're good. All right, so the goal is to get a variable to eliminate. So if a variable is going to eliminate, that means that you are going to have the same number but different signs. Because then when you add them up, you get 0. Before I can start doing any of that, bless you, you need to make sure your variables and everything are all lined up. So your x's are lined up, your y's are lined up, equal sign, number. So everything is lined up. Nope.
You put it on.
Okay. Angie? All right. So in my first example here, everything is lined up. Oh, I wrote it wrong. Plus 2y. And what variable do you notice that is going to eliminate? The y's. Because you have the same number but different signs. The reason why you need different signs is because if one is positive and one is negative, when you add them up, they will eliminate and go away. Because negative 2 plus 2 is 0. So when you add them up, they go away. Does that make sense? All right. So we're going to add up the rest of our like terms. 4x plus x. 5x. Bring down your equal sign. And 7 plus 3. All right. And so then how do I solve for x? Divide by 5. So x equals 2.
Oh my God, what's so hard about that?
It's not hard. All right. Tomorrow will be a little bit more difficult because it's going to be 3 variables.
I'm not going to be here tomorrow.
All right. Then you're going to take the x and you are going to plug it back in.
So which one?
Either one.
Okay.
All right. So you're going to plug it back in. You can pick either equation. It does not matter. I normally pick the one with the smaller numbers. So I'm going to use x plus 2y equals 3. I'm going to use the smaller one. And what am I plugging in for x again? 2, because x equals 2. So I'm going to plug 2 in for x. And then solve for y, minus 2 on both sides.
2y equals 1 divided by 2. Y equals 1.
So y equals 1/2. All right, so write your answer as a coordinate point 2, 1/2. And the checking part, remember that's optional. It's a good idea if you want to make sure you have the right answer. But I would save that until the end. All right, so I would wait until the end. If you have extra time and you want to go back and check, go back and check. But if you are one of those people that kind of take a long time to do stuff, I would get your answers first. And if you have time, go back and check. Because you don't want to not finish. Does that make sense? All right. Number 2. All right, I'm going to draw sticks on number 2. So don't answer unless I call your stick. Jasmine. What variable is going to eliminate? The x's. Very good, because 3 minus 3 is going to eliminate and it gives you 0. They have the same number but different signs. So Gitbrum, help me add up these 2 equations. Good. Okay, so 2 plus y, 2y plus y is 3y, and 6 plus 3 is 9. Okay, and then who's 8? And Marie, is that you? Yeah, it's you. What do you do next? Yeah, divide both sides by 3. And so then y equals 3. All right, Leslie, tell me what to do next. Right here. All right, which one do you want to use? Okay, negative 3x plus y equals 3 is the one that Leslie wants to use, which is fine. It does not matter. And Faith, tell me what I'm going to write when I plug 3 in.
When you plug 3 in,
Mm-hmm.
negative 3x plus 3 equals 3.
Okay. And Andrew, help me solve for x. Subtract 3. All right, what's 3 minus 3? Andrew? 0, okay. And then what else do you do, Andrew? By. And what's 0 divided by negative 3? Andrew, you can answer again. 0. Yay. So 0 is okay if you get 0. Why don't you like 0? Everybody is so against the number 0.
Because
Like, you can't just do 0.
It's just a number.
Zero is a sin.
You act like it is so, like, not allowed. It's like, I got 0, what do I do? It's like, nothing.
It's wrong.
It's not wrong.
It's like, oh, I did all of this and I ended up with 0. No, that ain't right.
Forbidden
That ain't
number.
right.
Yeah.
Don't go past the one.
Alright, so for those two problems for elimination, are we good?
Yeah.
Sweet. Alright, number 3. When the system does not contain a pair of additive inverses. So additive inverses means it doesn't have the same number but different signs.
Don't you like multiply both of them by like the least common factor or something like that?
Yes, least common multiple.
Can't you divide? Get multiple. Or something
You can't divide. You'll get fractions if you divide, so that's no good.
multiple. Yes. That's right.
Yeah.
Those are pants.
Yes, they're pants.
I love that. They have pockets too.
They have pockets, yeah.
Oh yeah.
Okay. So
I want some now.
we are going to be looking for the least common multiple on number 3. You have to get one of your variables to eliminate. Now, it doesn't matter which variable you pick to eliminate. You just decide. So, do we want to eliminate x or y? X. Okay, that's fine. You can do both. So, if I want to eliminate x, I want to get both of these numbers to be the same. And so what you have to kind of think to yourself is what number times 3.
5 and 3.
Yeah. So 5 times 3 is 15. 3 times 5 is 15. So you're getting the same number here. Okay. Another way to think about it, like, what 3 times 1 is 3. Is there a number you can multiply by 5 and get 3? No. 3 times 2 is 6. Is there a number you can multiply by 5 and get 6? No. 3 times 3 is 9. Is there a number you can multiply by 5 and get 9? Okay. 3 times 4 is 12. Is there a number you can multiply by 5 and get 12? No. 3 times 5 is 15. Can you multiply 5 by something and get 15? Yes. So that's what your least common multiple is. That's from way back when. I don't even know when. What's up?
Multiply 1.8 by 5.
I mean, you could, but I would recommend staying away from fractions. But I mean, if you really want to, you could.
15 times 5. Yeah, 5. There is 2. 75.
What is the least common multiple if you wanted to eliminate the y's?
2 and 7.
2 and 7. 14. All right, so 14 is the number you would be trying to get. All right, so I'm going to multiply this whole top one by 5. And don't forget to multiply every single number by 5. A lot of people forget to multiply this last number here. This number right here. Don't forget.
Don't forget.
All right. So, Faith, help me here. Multiply all of these by 5.
Okay, 5 times 3 is 15. X plus 2, I just put it down, 35y equals 75.
Very good. All right, now.
Moved in your calling on these things.
What do I do by negative 2?
Yes.
Back to our channel.
All right, so on this bottom one, it's not just going to be a regular 3. It has to be a negative 3 because you need different signs. So originally, right now, both of these are positive.
Did you just subtract it?
Yeah, that's what we like. You keep it as a positive 3, and then you just subtract.
That's fine, too.
Okay, just do that.
Ain't nobody gonna do that.
No.
All right, so negative 3
Multiply by
times...
negative 3.
It's the same thing, yeah. Negative 3 times 5 is negative 15x. Negative 3 times 2 is negative 6y. Negative 3 times negative 4 is 12. So, now these eliminate. 35 minus 6. 29y. Faith. Shh. 75 plus 12.
Oh, plus
Uh-huh. 87.
87.
Faith. Leslie. All right, 75 plus 12 is 87, and then we're going to divide by 29.
Isn't it 3?
Uh-huh.
I'm just guessing.
It is. And you get y equals 3.
Okay, Terry, put it in reverse.
All right, once you get your y, you can plug it into any one of your equations. You can plug it into one of these or one of these. I would choose the equation that has the smallest numbers, though. So I'm going to plug it into the bottom one. So I'm going to plug it in 5x plus 2y equals negative 4. And I'm plugging in 3 for y. Okay, so now I'm going to solve. Anybody want to help me?
Sure.
All right, Emery. Multiply 2 and 3. Get 6. Subtract 6 from both sides. 5x equals negative 10. Very good. Divide by 5. So negative 2. So your answer is negative 2, comma 3.
Yes.
All right, flip it over on the back. All right, I want to talk about 5 and 6 real fast, and then I'm going to let y'all do number 4 on your own. But 5 and 6, it was kind of like that practice when we did. Do you remember the infinity answer?
Oh, no.
All right, so I just want to talk about why it is that. All right, so on number 5, what do I want to eliminate, x or y?
X.
X, sure. It doesn't matter. So I want to get these to be the same number but different signs. What do you have to multiply this whole equation by to make your x's eliminate? A 2, right? A positive 2. Because if I multiply it by a positive 2, the x will become a negative 4. The top one, do you need to multiply the top one by anything? No, so you don't always have to multiply it by something. So the top one's going to stay the same. The bottom one I'm going to multiply by 2. So negative 4x plus 2y equals negative 6.
Oh,
Oh,
it's
no.
the exact opposite.
Bro.
All right, so now what happens?
What the heck
It's
does
the
that
exact
mean?
Everything cancels, right?
No solution.
All right, so I get 0 equals 0. So think, does 0 equal 0?
No.
Yes. So because that makes sense, your answer is going to be infinity solutions.
Bro.
It's kind of like pushing the zeros together.
That's a cheat code right there.
All right, jump over to number 6.
Oh, I have a question real quick.
Yeah.
Number 5. So like, let's say that it's a different test. So like the answer is infinity. Would like the one of the answer choices be like all real numbers or like
It'll say infinite solutions.
infinite solutions?
Yep.
Okay.
All right, good. So, hey.
I can't see it.
All right, on number 6, I'm going to multiply, if I want to eliminate x, and Kanai told me she's going to multiply the top one by negative 2. Has to be negative because I need different signs, so they eliminate. All right, so on the top one, negative 4x plus 6y equals negative 36. The second one is going to stay the same. We don't need to do anything to it to get your x's to eliminate.
No.
All right, so the x's eliminate and the y's eliminate, right?
Yeah.
So I have 0 on this side equals negative 24. Does 0 equal negative 24? No, it makes no sense. So this one is a no solution.
What would that say? No solution?
Yeah.
That's not even work here.